Hello everyone and welcome back. So this time we're going through a second example. We're going to be focusing on the parallelogram method this time. Now, what are we given? Let's go through the problem. So first off, we're given a force acting on a pipe, and you can see that force right here. It's 30 pounds. So we used newtons last time, pounds this time. This is the USCS system, United States customary system. And we have a force and an angle. Okay. But what it's telling us to is to do something different. We're not trying to figure out what's the horizontal and vertical components. No, we're picking two arbitrary directions. We want to figure out what the components are along those directions. So with this, we would need to use the parallelogram method. It's the easiest way to solve this kind of problem. You can still solve it with other methods, but it just gets wonky. Parallelogram method is the best way to do this kind of problem. So we're going to get into components along the U and V axes. You're like, well, what's the difference between the X and Y axis and the U and V axis? Is it just a different name? The difference is that this right here is not a 90-degree angle. So it's not the same thing as our X and Y axis. So we can't use sine of theta, cosine of theta, the simple like triangle identities to solve this problem. Okay, so how are we going to solve it? Well, first off, I'm going to move my head out of the way. There we go. We're going to construct lines that are parallel to the U and V axis and form a parallelogram. We're going to resolve those forces into the U and V components and then find the magnitude of the components from the law of sines. Law of sines, magic. This one's actually extremely helpful, both in this and other classes. So please memorize the law of sines. The law of cosines, it's still helpful, but it's harder to memorize. But this one, definitely worth it. Okay, so here it is. Public service announcement. Go and try it. Don't click forward through the PowerPoint. Don't keep on watching the video until you've actually tried the problem. Try to finish it on your own. If you get stuck after 5 or 10 minutes, come back, finish the video. Okay, so 1, 2, 3. Okay, with that, you've hopefully tried the problem. So let's get to it. I'll move myself over in the corner now. So how do we solve it? First off, we have to draw our parallelogram. I'm just in the way all the time today. There we go. So you see this, we have a parallelogram right here. And it looks good. We can figure out quite a few of the angles if we want to. And we'll have to do some trig to do that. And then from this, we should be able to figure out what the V and U components are using the law of sines. So here it is. And we have 105 degrees here, 30 degrees here, and 45 degrees here. Now, where did that come from? How did they know that? Math is hard. Should we just give up? No, you shouldn't give up. So let's actually talk about where this came from. So first off, I'm going to redraw this so that we can figure it out. Okay, and we have something like this. So this is the y-axis right here, and this one right here is the v-axis. What we're told originally is that this is 15 degrees. Now, if I make a little right triangle here, I see that this is 90. Okay, so 15 is this angle right here. Let's actually clear up a little space. 15 is that angle right there. So how many degrees are in a triangle? There's 180. So if this is 15, that's a 90. That's 105. That means that this right here is 75. So there's 180 degrees in a half circle. So it means that this is 105. Okay. 30 degrees was right here. From similar triangles, this must also be 30 degrees. And then if we want to have the whole 180 degrees in a triangle, 135, 180 minus 135 would be 45. So that's where all of those numbers came from. It's not hard, it just requires a little bit of thought to make sure you do that right. And my honest opinion is, please do not try to fly through this. You will hurt yourself if you're going too quickly, because you'll make a mistake. You'll do 65 instead of 75. Asking my students, I do it all the time. So if I do it, you're probably going to do it too. Or maybe you'll be completely better than I am. So, you know what? I'm believing that. You're going to be better than I am. You're going to do better than I am. You're not going to make any mistakes. So, rock that. Okay, now we want to figure out what the U and V components are. We need to figure out what they are. And we're going to do that using a pin that works. There we go. So to do that, we use the law of sines. The way the law of sines works is you have an angle and you have a magnitude. and it's always the side that is across from the angle. You see how B and C, they're both touching this side? A is not. So whichever angle is not touching that side, they're connected. So these two are connected, and these two are connected. And finally, the last two are connected. We know one of the magnitudes, and we know all three angles. So we know more or less, we know this, we know this, we know this, and we know this. As you can probably guess, I have one equation, one unknown I can solve. And I have a second equation, one unknown I can solve. So super easy right there. I just use my sine functions, plug it all in, and I get 22 pounds for one and 15.5 pounds for the other. If you want to check this, try the whole a squared plus b squared is equal to c squared thing. Okay, now hopefully you realize that's horribly wrong. I'm going to say this because you're going to think to do this at some point. That's not it. That works for a 90-degree triangle. It has to be a right triangle. These are not right triangles. This will not work. Remember that. Don't forget that. If you actually look at the whole law of cosines, it's equals a squared plus b squared. This out of the way again. Minus 2ab cosine of c. This is Pythagorean theorem, and then this is the correction to Pythagorean theorem because it's not a right triangle. Okay, so with that in mind, Pythagorean theorem does not work if it's not a right triangle, but law of sines, law of cosines works for anything. Does not matter if it's a right triangle or not, it will work for any triangle. So try them out, memorize them. I also have another example problem that's just written down for you if you want to look at law of sines and cosines to reference. Okay, well, I hope this helped you. And next time we'll go over a little more difficult problem. So I'll see all of you then. Bye-bye.